Alright, in this section here, we're going to be talking about piecewise functions. So we've talked about what a function is, and this time our function is going to be cut up into pieces, and it's just that simple. Also, they may call these branch functions, but I'm just going to call it piecewise functions, piecewise defined functions. So of course we get started here. Woo, that's a terrible graph. Let's try redrawing. Try to redraw that a little bit better. Whoa, I'm not sure if that was any better or not. This is what a piecewise function looks like. So let's say that part of our function does this. I'm going to put an open circle right here. And then let's say that the rest of our function does something like that. Okay? And that's going on that direction and coming from that direction. So that's a piecewise function. What would not be a function is if I filled in this dot right here. Okay, so if I were to fill in this dot, then that basically means that we'll label this 2. That means that when I plug in f of 2 into our function, we would get out, we'll say that's 2, and we'll say that that's 3.5 or something like that. This right here. You know, we would get out 2, and we plugged in f of 2, we'd get out 3.5 also, and that's not a function, remember? Because remember, in a function, let me just write both these ordered pairs here. So that would be 2 and 3.5. So remember, in a function, these guys can't be the first coordinates in this relation. If it's going to be a function, you can't have two ordered pairs with the same first coordinates. Okay, then that's not a function. So we got to have a hole. There's a hole right here, or a hole here. Either one. All right, let's actually work an example now. I'm going to define my piecewise function f of x to be equal to, and this is how we would do it. Put a big curly bracket here, and we're going to do this, and the domain for this part of the function is x is greater than 0, and the domain would be x is less than or equal to 0 here. So let's graph this. So you see the function's in two pieces, okay? So this part up here, this is just a constant. So this is like writing f of x is equal to 1, except we define our domain to be x is greater than 0. Alright, so we graph this piece here. So that's just, we'll say this is 1 here, and x is greater than 0, so I need to put a hole right here because we don't include 0, and then it's just a constant. You see, going straight across at 1. Okay, so no matter what I plug in for x, it's still going to be 1 out. Now let's graph this one here. We'll say that down here is -1, and of course this includes 0. You see the equal sign here? This includes less than or equal to 0. So I'm going to put a solid dot, and that would be everything going off in this direction here. So any of the negative numbers I can plug into this guy here. So let's say that I wrote it like this. Alright, this, you know, writing this to describing this graph up here is, there's a better way of doing this, and that is we just write it like this. You see this? We just write it just like this right here. Big curly bracket, and then we put in each one of our separate parts of our function here, our pieces. So these are called our pieces here. Alright, so it's really just that simple. Okay, so let's look at another one. Alright, so we're going to define, you know, and I'm always calling my function f. You can call it anything you want. Alright, and x is greater than or equal to 0 here, and we'll let this just be 0 with x is less than 0. So you try graphing this out and then come back and see if it's the same thing I got. So let's go ahead and look at this top one up here. So we're graphing, if you want to look at it this way, I'll write it like this. We're graphing f of x is equal to 2, and our domain is x is greater than or equal to 0. So 2, we'll say 2 is right here. Just arbitrarily pick a spot. And it must be greater than or equal to 0, so that means we can take an x or take 0 and plug it in and we get 2 out. Alright. And so we end up getting just a horizontal line, okay, going off in that direction. And then of course let's graph f of x is equal to 0. This time we don't include 0. So I'm going to put a hole in the graph right here, and it's everything. Now f of x equal to 0, that's actually the x-axis, isn't it? You know something, let's do this one in a different color so we can see it. Okay, so we're remaining on the x-axis and going off in that direction to negative infinity. So it's not too bad graphing piecewise functions. Let's look at another example, of course. Okay, and this time we're going to look at, and of course I know f is overrated, but I tend to use it a lot. Alright, let's see, let's look at this one here. So we do curly brackets, f of x is going to be equal to x, and our domain is x is greater than or equal to 0, and then our second part of this function is a constant 3, and x is less than 0. I guess if you want, you could put a comma in here. Seems like I see commas or something separating these guys. Okay, so what does this graph look like? F of x is equal to x where x is greater than or equal to 0. Well, this is going to be, now we're including 0, so I'm going to put a solid dot starting right here. Okay, so this graph, and you know what, we'll do this in a different color. Looks like this. It's got a slope of 1, right? So it's going off in that direction forever. And then we do the second part to this graph. Of course, we don't have to write this. I'm just doing this if you're seeing this for the first time. Okay, so this is a constant, 3. So let's say that 3 is up here. All right, we'll say 3 is up here. And we're going off in that direction. And that 3 just can't, just how about right there, okay? Now of course we put a hole in the graph. I put an open circle here saying, look, at C0 it's not defined, okay? It's not defined. So here's the question, what is f of 0? Do you use this one down here, or do you use this one up here? Well, you would use the top one because we can include 0 in our domain. So that would just end up being 0. This is the one we would use. F of 0 is 0. See? Down here. Okay. Alright. Hopefully you're getting the trick of this. Actually, I guess there's no trick. Get the hang of it. We've already graphed linear equations, and now we're just graphing 2 of them. And they're cut up in 2 different pieces. You know, I think I'll name this one something else. How about h of x? We'll give it the name of h of x, and we're going to say 2x plus 1, where x is less than negative 1, and then the other part to this is x, where x is greater than or equal to negative 1. All right. So this part, 2x plus 1, it's got a y-intercept of 1. Now, what we need to probably do here is I'm going to plug negative 1 in to this. Even though it says we're not supposed to use negative 1, we're just going to Right, -1. Now, I need to say this again. This says we don't include -1. And what am I doing? I'm plugging it in anyway. Well, I'm doing that because we can at least see where that open circle is. So here's -1 on the x-axis, and we'll say that this is -1 on the y-axis, and so the hole is going to be right there. Now this thing has a slope of 2, so we need some more room. I'm just going to kind of guess it and make the line look like that. Okay. Let's go ahead and graph this other part, h of x, which is equal to x, and our domain is x is greater than or equal to -1. So this time we include -1. So I don't feel so bad now plugging -1 in, and we get -1. So I take -1 and I plugged it into our function, and we actually get -1. So guess what happens here? I'm going to put this in a different color. We're actually filling that dot in now. We're filling it in. And to graph this, it's going to look like going to look something like that. I'm trying to make the slope of this red line a little bit less than the slope of the blue line here, because the slope of this line, this has a 1 as a coefficient, so its slope is just 1, right? This has a slope of 2, so it's going to be a steeper slope. But anyway, this is the graph. Now look here, it's all in one solid piece now. See that? Of h of x, right? So hopefully you're getting the hang of this up to this point. What else have I got in store here? I got any more examples? Yeah, I got another example here. Okay, let's look at maybe one more. Oh boy, we're in red. I guess that's okay. It's nice to see different colors every once in a while. -3x plus 1, and x is not equal to 2. What does that mean? And then 4, x is equal to 2. Okay. We'll go ahead and go back and use the black marker. Okay. Oh, I don't know if I told you this or not through all these videos or whatever, but you know, this is a whiteboard, and I'm actually standing up here in front of this whiteboard, except I'm wearing a cloaking device. You can't see me. Isn't that interesting? You cannot see me. I am standing in a classroom, and you can't see me. I've got this new technology. Okay, let's see. Let's go ahead and graph this guy. Now I'm going to just say something here, because this says x is not equal to 2. What about all the rest of the x values? Okay, we can use we can use the whole real number system, all the reals, except we cannot use 2. That's what we're saying here. Alright, so we need to go ahead and graph this. So the y-intercept is, we plug 0 in for x, we get 1 out. So we know it crosses here. Actually, you know what? Let's find out where the hole is, because there's a hole in the graph at 2. So why don't I do that? Even though it says not to use 2, I'm doing it anyway because we want to find where this hole is. Alright, seems like I'm telling you one thing, and then before you know it, I'm doing the next. -5. So at 2, which we'll say this is 2 here. At 2, we have a hole at -5. Okay, which is about right here. All right, which means that our line is doing something like this. Now keep in mind that there is a hole in the graph right here. Okay, there's a hole. And we'll just extend the line down. So there's a hole in the graph right here when x is equal to 2 because it's not defined at 2. Alright, now what about that mystery? Well, this is f of x is equal to 4 only when x is equal to 2. Okay, only when x is equal to 2. So we plug 2 in, and the only thing we get out is 4. And we'll say that that's up here somewhere. It's just a dot. That's all that it is. It's just a single point. It's just a single point. And so in other words, in this function up here, when I say, okay, what is f of 2, you can't use this one because we're not allowed to use 2. But we can only use this one, and the only thing out is 4. What if I said f of 0? Which one do I use, the top one or the bottom one? Well, the bottom one says we can only use 2, but the top one says we can use everything but 2. So that means we can use this. So you plug 0 in and you get 1 out. So plugging 0 in, we get 1 out. Okay? So that's how these piecewise functions work. Now, I think, I'm not going to really work any more examples, but I'm going to talk about some other things that are related to the piecewise functions. We're going to add a few things to this. Okay, so let's just draw a graph because a picture is the best thing to look at. In these examples that I've been giving, we have been only working with 2 different functions. Okay, but we could work with 3 if we wanted to, and here's an example. Let's say that it happens to do something like this, so that would be like 1. Let's make that a red line, and then let's make the next function here a blue line, and then we could have something like this. We'll make a solid dot, and then I don't know, we'll do purple on this next one here. So we've got something written here and it's in purple, and let's say that it does something like that. So as you can see here, you can have 3 different. You can have as many as you want. Okay, as many as you want. As long as the whole thing satisfies that it's a function. Alright, we could, this is something, I don't know if we did one of these examples, but you could do something like this where you notice that our function, this part of our, well, this is, we'll say this is 5 here, and this is 3. But the stuff between 3 and 5, right, this stuff in here, including 3 but not 5, is not in the domain of our function, you see. So you could have a gap. You could have a gap right here. Alright, it's not defined in your function. Okay, so picture's worth 1,000 words. The whole idea is just have to graph each one of these. That's kind of really what takes up all the time. Okay, so I think I'll end it there on graphing piecewise defined functions. Alright, piecewise functions. So good luck with all that.